We just recreated this shot from the Batman in less than 24 hours in Unreal Engine 5.
To pull off a shot like this, you need tons of manpower,
Hundreds of thousands of dollars,
permits to close down highways,
fake rain,
flipped cars,
a Batman suit,
fire,
expensive cameras and lenses,
and many more.
or you can just use Unreal Engine at home. And that's exactly what we did. And that's what we're gonna teach you in this video.
First, we are gonna pull up our reference to know exactly what our scene looks like.
The pre-production phase is perhaps the most important phase. The more nuanced we are in referencing, the smoother our creation is going to be. We're recreating this specific Batman scene. So in this scene, we're right at the moment after the car chase between the Batman and the Penguin. The Penguin's car is flipped right upside down, and he's now staring into what appears to be Batman coming out of the Batmobile to come and hunt him down. But it is not just what's happening, but what is in our scene that makes this scene so juicy. If we pay close attention, we have heavy rainfall, which just makes it so much more dramatic.
It's almost flooded on the surface if you see.
And we have a huge fire roaring in the back, which creates such an immense light source behind the Batmobile, behind Batman, meaning everything in front of the fire is technically just a silhouette. It's almost pure black. Let's pay close attention to the items that we have in the scene first, then we'll get to the colors and the lighting. We clearly have the Batman, we have the Batmobile, we have
Penguin's car frame, so you can see it through that window.
exactly, because we are looking at Batman from Penguin's point of view.
Yes.
So we clearly need a car that is upside down, outside of which we're on a highway, right? So you see the floor, which is flooded, as you mentioned, but we are looking at a highway. Therefore, there are street lamps or highway lamps on either side. We've got barricades around the highway. We've got car debris on the floor from the car crash. And aside from that, I think we can just talk about everything else that we see. Because of the fire, perhaps, we see a lot of smoke at the top of the frame. And at the same time, I see a lot of fog in the scenes. And this fog, we can of course recreate using volumetric fog. Let's talk about the lighting in the scene. We clearly have the highway lamps that are emitting light, but I think the biggest light source here will just be the fire. I don't know what they were doing behind the scenes. They probably have other fake light sources, which we will have to also recreate in our scene, but we'll only get into the nitty-gritty detail of that later on. We also have to look at some wind, because as Batman is walking towards Penguin,
You see the cape flowing in the wind.
exactly. And the last thing I want to touch on is that the colors that we're looking at is mostly saturated orange, perhaps because of the fire once again. So we've covered the referencing phase. I think we all have a clear picture as to what the scene should look like. I think we should get inside Unreal Engine and recreate the scene.
Let's go and make it.
Now let's begin by creating the scene in Unreal Engine. Inside our new level, the very first thing we'll do is bring in a mannequin so that we have a reference point. Our brains have been designed for thousands of years to recognize humans. And so to get a sense of scale, it's always best to compare our scene to a human scale.
Now, let's design our base floor, which is our highway. We are not going to use the default floor. We want to create our own. So we will switch to modeling mode, select rectangle, and create a flat plane. We are setting the width to 2000 and the depth to 5000. This will represent one side of the highway. Later, we'll duplicate it to create the full highway. Once that's done, delete the default floor.
We have our floor and the mannequin reference for Batman.
For the Batmobile, we are going to use a model from Sketchfab. We put down the link in the description, and this is going to be the case for any 3D asset we use from now on. This is the only model we found that matches the silhouette of the Batmobile from the movie. We'll download it as a GLB file and import the model with combined static meshes checked, so each part of the car does not import as a separate mesh.
Let's drag the Batmobile into the scene. Beautiful. Now don't make this common rookie mistake. If you're making a video game, you have to build the entire environment. But when you're making a cinematic film or animation, like we are in this case, you only have to make what the camera sees. So don't spend hours fine-tuning things that do not end up being in the final product. In order to honor this rule, we're going to set up our camera compositions early so that we can constantly verify what our shot looks like. Let's therefore bring in our cinematic camera into the scene. In the Batman, the camera is far away from Batman and it's flipped upside down, because that is Penguin's view in the car. So we'll flip the camera by 180 degrees.
Now, Penguin sees Batman through the window of his vehicle. So now we need to place the camera inside his vehicle. For that, we are going to use another 3D model from Sketchfab. We will download it as a GLB file, combine static meshes, and import it. We will scale the car down to its correct size and fix its pivot point with a modeling mode, because it was offset by default, which makes transforming the car complicated. Then, we'll flip the car to match the reference and position the camera inside the car. We'll even stretch the car's scale unevenly as needed to fit perfectly in the frame.
In the film, you can't see the car's side mirror, so we need to remove it. We'll switch to modeling mode, select Mesh Triangle Select, and carefully select the mirror parts to delete them. And now we're going to set up the floor material. We'll search for Quixel Asphalt in Fab Marketplace and download the material in RAW, which is 8K resolution. Juicy.
Juicy.
And apply it to the floor once you're done. To get the scale right, we'll adjust the tiling, using the mannequin as a reference to judge the scale.
For the highway lights, we are going to search for street lamps in Sketchfab and download the model as an FBX file. This gives us more control during setup. We'll import the model without combining static meshes so that we can choose our preferred lamp in isolation. Fix the pivot to the bottom for simplicity. Now, we need to set up the materials. For the metal parts, we will use the metal rusty material from the starter content. For the light itself, we will create a material with an emissive color. We will add a multiply and a scalar parameter to control the light intensity.
To clone the lights along the highway, we'll be using the motion design tools.
Wait, what?
Yes.
Why motion design tools?
Well, I know that it's supposed to be used for motion graphics, but we've discovered that if you use it for scene building, it actually helps you speed up the process drastically. After enabling it, we'll use a cloner to multiply the lamps in our scene. We'll make the lamp a movable object, drag the lamp under the cloner, change the layout to line, and switch the axis to X to match our highway. Then we'll adjust the count and spacing to match the reference, and then duplicate the cloner to create lights on both sides of the highway. With the lights in place, we'll also extend the highway by duplicating the floor plane several times.
Next, we will add the barricades. Inside Fab, under the Quixel section, we will download the roadside construction pack. Once imported, we'll find the barricade static mesh. To save time, we'll duplicate the cloner we used for the lamps, replace the lamp with the barricade, and adjust the random rotation and offset to make the barricades look more natural and varied. Then, we'll duplicate the cloner again to put the barricades on the other side of the highway.
But just at this moment, we discovered something. Something that we even missed in our referencing phase.
So, we have these lights, both of them facing, barricade on one side, the other side has nothing. So barricade in the middle of the highway, and then we have the light.
So wait a second. So this side has barricade.
No,
so wait, we're
the-
looking from here. First of all, we're looking from the opposite
No,
side.
we are looking from the opposite
Yeah,
side.
yeah, so we're
his
looking-
right side has a barricade.
So my left side is gonna have these bars, no
Yes,
barricades.
No barricades, and then
On my right side is barricades, but now consider
Technically-
that it's upside
No,
down.
consider that this is a two-way highway. There is road here, so this light is further away.
So
this light is
okay,
closer to you.
So on my right side there are barricades, correct? And on my left side there's the bars. There's no barricades.
Listen, this is Batman car. On the right side is barricade, that's right. On the right side of the Batman car is barricade.
Yes.
On the left side is nothing and light. And the lights on the right side, which has barricade, is further away.
So we need to go to range and then change the rotation max to 180 degrees. So it's going to rotate everything. And
That's
instead it's further down to the right.
That's
Is
correct.
that what you're saying?
Yes, that's correct.
Okay. So, and then there are barricades on my right side.
Yes.
So which means this is going to be
No,
here.
no, that's correct. There is a highway here.
Oh.
There is a highway. See, there is a truck. So there is a highway here.
Okay.
Yes.
All right.
So
if
you
that
don't
is the
need barricade
case-
here, this side.
Okay, seen the movie as well? Okay, all right. So if we are to hide the barricades on that side. Okay, so here we need to go put in the bars, which is this guy.
Yeah, you can put those bars.
Okay, so that means
Beside the lights.
I can go and bring this here.
Actually, why did you
Wait,
delete the
once
barricades?
again.
You
No,
could
I
use
didn't
this.
delete the barricade.
Okay.
So I can go ahead and bring in my barricades, which is this one, and I'll delete what's inside it, and then I'll take this one, make it movable, and then bring it underneath. If I bring it, it's like this. And they don't need to be randomized, so actually let's not put an offset, so we need less of them. We didn't need like 50 of them, and we need more distance.
Yes.
Is it like
maybe
this?
a bit less?
Okay, let's see what that looks like. So we have the barricades now and the lights, and then we have this. Okay, this looks better.
Yeah.
This looks better.
Yes.
Farhad, what time is it?
It's the time to set up the lighting and the sky.
That's right. Let's get into it. For that, we'll use the Ultra Dynamic Sky plugin, which is incredibly powerful for creating realistic weather effects quickly, like rain. Drag the Ultra Dynamic Sky blueprint into the scene, and then we'll adjust the time of day to nighttime. We'll disable the stars, enable volumetric fog to allow light to react to fog particles, increase cloud coverage, and lower the overall intensity of the light in the scene. These settings we will continuously tweak as we build our scene.
Right after that, we are going to add a post-process volume, which is going to give us the ability to control exposure, bloom, vignette, film grain, and many more. We'll disable the Ultra Dynamic Sky exposure and control it from the post-process volume instead. We'll tweak exposure, bloom, and lens flare settings here to match the mood of the scene.
For rain, we'll add the Ultra Dynamic Weather blueprint to the scene. We'll increase the rain amount to about 10 to 15 and turn off thunder and lightning, since we don't need it. We'll also adjust the rain particle settings, such as raindrop scale, alpha, and sparkle, to make the rain more visible.
The rain is now starting to look really good.
Yeah, but it's not making anything wet.
What do you mean?
We need to make things wet because it's raining. Rain makes things wet.
How do we do that?
Okay, I'll tell you. To make the materials respond to rain properly, we'll need to modify the parent materials that control all the material instances present in our scene. Let's look up the parent material of our imported assets, and in their material graph, add in the Wet Weather Effects node, which comes pre-made with the Ultra Dynamic Sky plugin. We'll need to pass the base color, roughness, and normal through the Wet Weather Effects node so that the Ultra Dynamic Sky's rain can impact these materials. We'll enable Apply Dripping Effects and Apply Puddles by setting them to true using a static bool node. We'll also hook up a scalar parameter set to 1 for the mask wetness. And that's it. Once we apply these changes, the puddles and wetness will appear on the floor. Gorgeous! As long as you do this to the parent material of any 3D model that is present in the scene, they will react to the weather effects.
We will repeat this process for any remaining assets. As long as material wetness is on high in the Ultra Dynamic Weather settings, we are good to go.
At this point, we realize that our highway lamp lights are so small on the screen that sometimes they look like artifacts.
That's simply because Unreal Engine only has a few pixels to guess how the light should look like.
And that's something that usually happens with Lumen, so we can fix it by simply enlarging the light. To avoid any artifacts, let's make the lights more prominent by enlarging them. We'll use the modeling tool by going to Triangle Select, selecting only the emissive parts of the lamp and slightly extruding the geometry. It worked, but the extruded part is using the metal material. So let's use Edit Materials, and then we'll select the sides we'd like to be emissive and assign the light material to it. Et voila! You have now bigger lights that do not look like artifacts.
Yay! We've also noticed that Penguin's car glass is still in its place. We will remove the glass using Triangle Select and delete it. Now, the rain should be clearly visible from inside the car.
To enhance the lighting further, we'll add rectangular lights. For example, we'll place a hot orange light to simulate fire's emissive light source behind Batman. We'll also add a thin light close to the floor near Penguin's car to highlight the ripples in the puddles. This small trick really enhances the realism.
Now, this scene wouldn't be a car crash if we don't have car debris on the floor.
No, it wouldn't.
So let's bring in some car parts to add debris to the scene. We'll download a few car parts and tires, import them, adjust their size and pivot points, and place them in front of the Batmobile based on the reference.
Once the car parts are placed, the scene is really coming together. We now have the wet floor, the rain, the barricades, the lamps, and the car debris, and everything is starting to feel cohesive. The next steps will be to add fire, bring in Batman, add cloth simulation, and make some final tweaks to our lighting.
By the way, if you're enjoying this learning experience, we have spent the past 5 months to create the ultimate Unreal Engine course for people like you who are serious about learning Unreal Engine and want to break into the industry and make money.
We ourselves have used Unreal Engine in the past few years to scale our business from 0 to 7 figures. And that's only because Unreal Engine allowed us to be incredibly versatile. We managed to work across the gaming industry, the animation industry, even the commercial and ad space within a few years. So the reason why we're telling you this is because we've got a limited time offer only for the people who are watching this video. If you want to know about the offer, use the code in the checkout that we provided to you in the description box below. Let's get on with the video.
For the fire, we are going to use a powerful and easy to use particle simulation software called Embergen.
Now, Embergen is free to use. However, you are going to need a paid subscription if you are going to export out your fire simulations.
So how they can get the fire?
Well, we're going to create the fire for you. We're going to show you how we made the fire, but we're also going to provide you with our fire simulation exports so that you guys can follow along.
How can they get it?
Well, if you guys sign up to the newsletter with the link in the description in the box below, we'll send you all the files. For the folks who are interested to know how we created our fire, here it goes. The fastest way to create fire is by using a preset to begin with, one that looks closest to the fire in our scene. Oil fire preset seems like the victor. Now, let's take a quick look at how Embergen works. First, we need a basic shape that acts as a primitive to emit the fire from. This could be a box, a sphere, a cylinder, or other shapes. Then we have the emitter settings, where we control how the fire particles are emitted. We have forces, which control how the fire particles move after they're emitted. And we also have simulation settings, which define things like the size of the fire, its resolution and quality, the amount of smoke. We also have color settings, where we define the color and look of the fire. This also can be changed inside Unreal Engine, so don't worry too much about it. Finally, we have the lighting settings, but these are only for previewing inside Embergen. They do not impact what we export to Unreal Engine. What really matters is the shape of the fire and the forces we give it, plus the simulation. That's how we control the movement and the dynamics of the flame. To control the fire, let's use forces. We'll add a force line and connect it to the forces. This allows us to control how the fire moves. Essentially, we're adding wind to the fire. For example, we want the flame to move from left to right, like our reference. Right now, the force is affecting the entire fire source, but we want to limit the area it impacts. To do that, we'll enable fall off, set it to linear, and adjust the fall off radius and inner bounds. This allows us to precisely control where the force affects the fire. Then we went ahead and added a few more force lines to really fine-tune the movement of the fire according to our reference. Next, we played with variables such as fuel amount and smoke dissipation to control the amount of fire and smoke that is in our scene. At this point, we'll check the simulation settings because we want to make sure that it's running at the desired resolution. If needed, we can increase the resolution for better quality, but keep in mind that this will make the simulations heavier. Once we're happy with the look of the fire, we're ready to export it.
For our fire simulation, we are using VDB file types. To export, we will add a VDB export node at the very end of the flow. In the export settings, we will export density and flames. These are the only attributes we need. For the frame range, we won't start at frame 0 because the fire is still building up at that point. Instead, we'll start around frame 50 and export up to frame 500, which matches the length of our animation. Embergen will export one VDB file per frame. So for example, 500 frames will give us 500 VDB files. This is the file we are providing to you when you sign up for the newsletter.
Now that we've exported the fire, we're gonna bring it into Unreal Engine. We'll create a new folder called Fire, and inside it, we'll drag in only the first VDB file. Frame 0, or frame 50 depending on where we started. Unreal Engine will automatically recognize the sequence and import all of the VDB frames as an animated sparse volume texture. Once imported, we'll add a heterogeneous volume into the scene, which will display the fire. However, the heterogeneous volume needs a material, not a texture. Fortunately, Epic Games provides a default preset material for this. We'll enable Show Engine Content, search for sparse volume, and copy the provided material into our project. Then, we'll create a material instance of that material so that we are able to access the parameters. And inside the instance, we'll assign our VDB sequence to the global texture parameter. Now, we can drag this material instance onto our heterogeneous volume, and the fire will play in real time in the scene once we check playing and looping. One thing to note is that we need to enable cast volumetric shadow in the settings of any light source that is impacting the fire. This ensures the light interacts correctly with the particles, casting shadows more accurately and therefore enhancing realism. Next, we played around with the material properties of the fire to create the look that we want. We adjusted the black body properties to enhance the fire and combined it with bloom properties in the post-process volume to give the fire that natural, bright glow. We also adjusted the temperature scale and density scale to match the fire and smoke look to our reference, reducing unnecessary smoke and making sure that the fire feels like it belongs in the scene. Farhad, when you look at our reference, I feel like there's something still missing.
There are a lot of fogs in our scene.
So what do?
We add the fog cards. When we add fog cards, we will actually add depth to our scene. These are 2D flat planes that have transparent fog materials on them, which you can manually place in your scene to art direct to the finest details. They can really spice up your scene incredibly easily and fast.
We use Dash Plugin's fog cards, which have pre-built features to control the fog material. You can also just go to a Quixel sample pack like Dark Ruins and migrate a fog card from there for free. We dragged in the first fog card, adjusted the size and rotation, tweaked the density and contrast to blend it in the scene, color to match the dark environment and the lights, edge fading to create a smooth fall off so the edges are not too sharp. By strategically placing multiple fog cards across the scene in the foreground and background, we added a lot more atmospheric fog. This dramatically impacts the visual richness of the scene.
We have to go back and play with our post-process volume and our lighting.
Lighting is everything, guys. It can make or break your scenes. You can have the best setup, everything done correctly. With bad lighting, all is going to fail. So spend some good amount of time to learn more about lighting and make sure you get it right. In the post-process volume, we added some vignette to center the focus of the viewer. Added film grain to diminish the CG super sharp and clean look.
As for our lights, we ended up with thin but incredibly wide floor lights with subtle intensity to bring out water reflections and floor details, playing with parameters such as width, height, attenuation radius, and barn door angles.
We added 2 small box-sized rectangular lights projecting into the air in both the right and left direction to really give depth to all the fog we have in the scene. Remember, this is why we turned on volumetric fog in the Ultra Dynamic Sky plugin earlier on. To ensure the lights don't reflect from the water, we just positioned them strategically behind the car, facing up, to the right, and to the left sides. Our goal here was to balance the lighting, fog, and fire glow to really match it to the reference that we have.
Finally, it's time
for Batman.
The Batman.
I'm Batman.
First, we need to download the Batman model from Sketchfab as a GLB file and bring it into Blender. However, this asset is not prepared for our use case. We need to make modification to it to be able to give it a walking animation and have his cape simulated in Unreal Engine.
These modifications were done in Blender and Miximo, and for your ease of use, we're actually providing you the modified asset if you sign up for the newsletter. Now, we also want to give a shout out to the creator because without him, this wouldn't be possible. So make sure you guys go ahead and check his work out and give him some love.
After importing Batman into Blender, first we deleted any previously made animation, rigs, and weight paints, as we will be making our own. Then we isolated out the cape as a separate mesh so we can only use the body to rig and animate in Miximo.
We'll export just the body mesh without the cape and upload it to Miximo, which is a free rigging and animation tool. Miximo will generate a rig, and then we can select an appropriate walk animation. In this case, a nice slow walk. Then we'll download the animation as an FBX file.
Back in Blender, we will import the animated Batman FBX file. Next, it's time to attach the cape by switching to rest position so everything lines up perfectly. We will select both Batman and the cape and use transfer weights to ensure the new bones influence the cape accurately.
In transfer weight settings, we'll set by name and use a radius of about 5. This ensures that the cape is properly weighted. And now we're gonna fine-tune the weight paint for the cape. We want only the top part of the cape to be influenced by the body. The rest will be simulated as cloth inside Unreal Engine. To do this, we'll go into vertex groups and lock the bones we want to keep. Then we'll delete all other unlocked groups so only the top is influenced by the body, and the rest will be free for cloth simulation. Finally, we'll add a very small amount of weight to the lowest spine or hip bone just so that the entire cape follows the body smoothly. Before exporting, we need to assign a unique material to the cape. This is important because in Unreal Engine, we'll use this separate material to isolate the cape during cloth painting. We'll duplicate the cape's material and assign it to the cape mesh. Now, we're ready to export this all as an FBX file, fully prepped for Unreal Engine. This is the file that we're gonna provide to you when you guys sign up for the newsletter.
Now, it's time to bring Batman into Unreal Engine. We wanted to set up his cape simulation, so we opened up his skeletal mesh asset. Since the cape has its separate material, we can simply right-click and create clothing data for it. Then right-click it again to apply the clothing data. Once that's done in the clothing window, we will select the new clothing data created and use Activate Cloth Paint to paint the desired part of the cape that needs to be simulated. We will only need everything below his shoulder. Ran a quick test here and realized there is something wrong. The bones automatically generate collision boxes inside Unreal Engine, so nothing goes through the body. However, our hip and shoulder collisions are clearly too large.
We're gonna fix that by heading to the physics assets, where we have access to the collisions. We scale down the oversized hip collider and shoulder colliders to avoid unwanted collisions with the cape. And now if we test the cloth simulation inside the skeletal mesh tab with some wind, it should work just fine. All right, let's bring Batman into our scene by dropping the animation sequence in there. To test if things are working, we're gonna hit simulate, and boom, the cloth is clothing.
What?
The cloth is clothing.
What does that mean?
That means the cloth is working.
Okay.
Boomer. But we ain't got no wind yet to push the cape, and Batman is just moving in place. For the wind, we're gonna add a wind directional source and point it towards the direction we want. We increase the strength and speed to about 10 and simulate. Et voila. Farhad, did you see that?
Looks majestic. To animate Batman moving forward, we created a level sequence, dragged in Batman, assigned the animation, and extended the sequence to 500 frames. We then adjusted the play rate to slow the animation for a more slow motion walk, added transform keyframes to animate Batman moving forward linearly without acceleration and deceleration, using linear interpolation. Now, Batman walks through the scene with proper motion. Seems like we are done, right?
No!
Why not? Looks good.
Listen, I'm gonna give you one big fat secret to achieving ultra photorealism. Are you ready?
I'm ready, let's go.
So we're using Lumen to render our scenes, right?
Which is great.
Which is fantastic. Lumen is incredibly fast, it's real time, and it looks super real. But it is still not as accurate and photorealistic as a path tracing rendering engine. A path tracing rendering engine, however, comes at a cost of speed, right? For context, this scene that we rendered, which is about 5 seconds, 4K quality, took us less than 30 seconds to render. I can only imagine in a path tracing rendering engine, it would take at least more than 6 hours. 30 seconds, 6 hours. Huge difference. Now, the problem though is when we have things like VDB volumes with fire, what the limitation of Lumen is that we will not see the reflections of the fire in our water. However, if you were to just quickly switch to the path tracing renderer, we'll see quickly that the reflection of the fire is now available and present to us on the water. That's because path tracing rendering engines are going to actually shoot out rays in every part of the screen and then see what that pixel will look like, which is why it's slow. So our trick is to always switch to path tracing and lumen just to see how the lighting and shadows work. Because if we can mimic what the path tracing rendering engine can do inside Lumen by faking lighting, then we can kind of push Lumen past its potential to get it closer to path tracing.
Thank you very much for the tip. Thank you.
Master.
So clearly we're missing that reflection of the fire in the water. So let's fake it. We're gonna add a new rectangular light near the floor. We're gonna match its color, intensity, width, and position to align with the fire. And then we're gonna create a custom noise texture with a circular fall off to mimic the soft flickering behavior of fire and to avoid the rectangular edges of our light source. This texture we're gonna provide to you also when you sign up for the newsletter. And now, as you can see, the technique simulated the fire's reflection beautifully on the wet floor surface, even with a Lumen rendering engine.
At this point, we have Batman walking,
Cape moving gloriously with cloth sim and wind,
fire roaring in the back,
rain falling like cats and dogs,
fog adding depth,
fire reflections on the floor,
fine-tuned lighting and post-process.
and the final thing to do is to render. So we're gonna go to render settings, switch to PNGs, choose our output folder, set the render resolution to 4K, and hit render. That's the reason why we love using Unreal Engine. I mean, let's be honest. If this was any other 3D software,
We would be dead.
this probably would have been hell for us. The only reason why this entire process was genuinely enjoyable for us to create was because of how fast Unreal Engine is, which means we can play with cloth sim, rain,
Fire,
fire, multiple assets with 8K resolutions and incredibly high poly geometry, everything running in real time without any loading, which allows us to be super creative. If this wasn't the case, this entire process just wouldn't be as fun, which is why we urge you guys to try and experiment and learn Unreal Engine to really harness the power and be as creative as you can be. We truly enjoyed the process. We hope you guys did as well. Farhad, how do you feel about this?
I feel amazing. If you guys like this video, make sure you subscribe to this channel because we are gonna create more remakes in the future.
That's right. The next tutorial is gonna be about Maya,
What?
Houdini,
No!
Cinema 4D,
Unreal Engine all the way,
3ds
baby.
Max.
Unreal Engine.
Blender.
Bye.